everyone, welcome to the session on geniuschalk. Today we will be discussing HCF and LCM, fourth part. So let's start the session. First question says, the product of two co-prime numbers is 965. Find their LCM. Now, for this we must know what is co-prime number. Let's take a number 2 and 3. Can we say that these are co-prime? Yes. Why they are co-prime? Because their HCF is 1. So those numbers which have nothing in common, they are known as co-prime numbers. So 2 and 3 are co-prime because their factors are like 1, 2 and 3 factor is 1, 3. We can see that 1 is the highest common factor in these. So those numbers are co-prime numbers. So this is the meaning of co-prime. Let's take 3 and 6. Are they co-prime? No. Why? If you write the factor of 3, it is 1 and 3. If you write the factor of 6, it is 1, 2, 3 and 6. Now HCF is not 1. We can sense it. HCF is not 1. 1 is common factor, fine. But highest common factor among both is 3. That means we can say that 3 is the HCF in 3 and 6. Obviously, you know this 1 into 3 and 3 into 2. So highest common factor is 3, right? So co-prime numbers are those which are having HCF 1. Now it is given that there are two co-prime numbers whose product is 965. And what is their LCM? Now taking the example which we have just taken, if I say that the number is 2 and 3, suppose these are the two co-prime numbers. What is their LCM? Their LCM is 2 into 3, 6. Suppose you take any other two co-prime numbers. You take 3 and 5. What is their LCM? It is 15, right? Suppose you take 5 and 7. What is their LCM? It is 35. So product of two co-prime numbers is always their LCM. So if the product is 965, can we sense the answer now? Yes. We can say that if the product of two number it is 965, that means taking example of 2, 3, what is the product of 2 and 3? It is 6, which is equal to their LCM as well. What is the product of 3 and 5? It is 15, which is equal to their LCM. What is the product of 7 and 5? That is 35. This is also equal to their LCM, right? So whatever is the product, the same has to be the LCM as well. So that's why I will mark the answer option B, right? I hope it is clear. Let's move on to the next. The LCM of, these are basic fundamental questions. The LCM of three different numbers is 150. Which of the following cannot be their HCF? Let's take three different numbers on our own first, just to understand the concept. Let's say 2, 3 and 5. Now what is their LCM? You know, these three are co-prime. Their LCM will be 5 3 is 15 into 2, 30. So what is their HCF? This can be written as 1 into 2, or if you write the factor of 2, it is 1 and 2. If you write the factor of 1 and 3, it is 1 and factor of 3, it is 1 and 3. Again, factor of 5 is 1 and 5. What is the highest common factor? That is 1. That is 1, right? Now see, if I take some other numbers, let's say I take 4, 6 and 10. What is the LCM? LCM is the multiple of the highest number. So 10, 6 are 60. 60 is their LCM. Now, if 60 is their LCM, what could be their HCF? We can say that its factors are 1, 2 and 4. Its factors are 1, 2, 3 and 6. Its factors are 1, 2, 5, 10. What is the highest common factor, guys? It is 2, right? That means this must be present in the LCM also. So we can write 2 into 30. That means the learning is, whenever we find HCF is always present in that. So in this case, the the LCM is 60 and HCF is 30. HCF is 2, which is already present in the LCM. So we can say that LCM is equals to HCF into some multiplying factor. I hope you're getting my point. LCM is equals to HCF into some multiplying factor. Like the example which we have taken, in that 30 was the LCM, sorry, 60 was the LCM, which we have taken for 4, 6, and 10. 60 was the LCM, and all of the three are having HCF2. So the multiplying factor becomes 30. This concept will apply here. If there are three different numbers, right? If there are three different numbers, their LCM is 150. That means that must be equal to the HCF into the multiplying factor. As we have just learned that LCM is equals to HCF into some multiplying factor. In our case, that was 30. That means 150 divided by this multiplying factor must be equal to the HCF. Can I say this? Yes. That means what I can conclude, that this HCF, this multiplying factor must be a factor of 150. Then only that would be equal to the HCF. So basically what we need to look is, what are the factors of 150? If this multiplying factor is a factor of 150, then only it will cancel and give me the HCF. So now just check which cannot be the HCF. Now if you put here 150 by 5, the first option, does it cancel? Yes. In that case, my HCF would be 30. So this cannot be my answer. 10, does it divide by 10? Yes. 15 times. So this cannot be my answer. Does it divided by 15? Yes. It is 10 times dividing it. This cannot be. Does this 150 cancel properly by 18? No. So in this case, this has to be my answer, 18. I hope the concept is clear. So LCM is equals to HCF into some multiplying factor. If we want to find HCF, multiplying factor will be in the denominator, right? All right. Let's move on to the next. Find the greatest number which can divide this without leaving the remainder. We know that whenever this factor is asked, the answer is always factor is HCF. So just find the HCF of this, right? Whenever this is asked, find the LCM, because this is a multiple and this is a divisor. As we know that greatest common factor, another name is, sorry, highest common factor, another name is greatest common divisor, right? So let's apply. So basically what we need to do here is, we need to find the HCF of this. So let's find the HCF. Now, whenever we have three numbers, I have told you the difference method is the best if they are close. So find the difference of their factor. So this also will be divisible. So what is the difference here? You can see that it is 5, it is 2, it is 2, and this has to be 105. And what is the difference here? It is 330. 330 is the difference, right? Now we can write it like 225, 105, and 330. The HCF of all of the three differences, or the factor of the differences, must be the answer, must be the highest number. Now can you find the value of this? Let's try. Does it cancel by 5? All of them cancel by 5, but is any bigger number also possible? So 15, yeah, they are all divisible by 15 as well. Fine. Now, are they divisible by 25? This divisible by 25, this does not, this does not. So, and this also does not. So 25 cannot be my answer. Are they cancelled by 20? No, it's not cancelled. So other we will not check. So this also cannot be my answer. Now out of 5 and 15, what is the greatest one? As we have to look for the greatest one. So the greatest one is 15. That's why this is my answer. I hope the concept is clear, right? Okay. Next one. Find the greatest number which will divide all of these. Now, there is some remainder, right? Now, if I am dividing by some number and I'm having that remainder, first of all, the point which must click in the mind, that is, this remainder is the problem factor. Let's say I divide this some number by 72, and let's say I divide it by 5, and I'm getting some remainder. Let's say I'm getting a remainder 2. Can you tell me, is this 72 divided by 5? No. Why? Because this 2 is creating a problem. So first of all, I need to subtract the remainder. I have to make it 70. Now it will be cancelling 14 times and giving me remainder 0. That means in HCF question, whenever you have a remainder in every case, first of all, subtract that remainder. Then whatever number left, just check that for divisibility. So the conclusion is subtract this remainder 8 from every number. Then only the remainder will be divisible. So 328 minus 8, 320, 448 minus 8, 440, 968 minus 8, 960. Now these numbers are divisible by the highest number and they will be leaving remainder 0. Now we can check it. Now which number divide all these numbers? Obviously the highest common factor of all. Now just check. Let's highest common factor, greatest. Let's check from the highest one. Highest available option is 50. Are they cancelled by 50? No. 50 is cancelled. Are they cancelled by 40? If I put 40 here, 48s are 320. Fine. If I put 40 here, 41s are 40. Again, 4 left. 41s are 40. Fine. If I put 40 here, 42s are 80 and 160 and 44. So that means 40 is the greatest number. 32 is not that greatest, although all will not cancel maybe. But there is no need to check. As all the numbers are cancelled by 40, this is my answer. Now you could say that why I did not take the help of the difference method in this question. So if you take difference, you can take difference method also. But the problem is that is time consuming as numbers are small. So this becomes 120. What is the difference? Is 2, 520. And what is the difference here in the third case? This is 4 and this is 6. So 640, 120, 520. Again, if you find the HCF, 40 is that number which will cancel all. 50 will not cancel all of these, right? So you can apply anyway, right? It's up to you. So this is my answer, option C. Okay, let's move on to the next. What is the largest number which is divisible by 369, this one, and 9 remainder in each case? The same type. So now we have to subtract this 9 first. So what is 369 minus 9? 360, 720 minus 9, 720. 1449 minus 9 is 1440. Now check by options. 33 obviously will not cancel. 43 will not cancel. Either we can check these two. Now if you check 32, again 40, if you divide, it will not cancel. So only 24 is left. 24 will cancel all. Again, if you take the help of difference, it may take more time as the difference is more. You can solve like, okay, this is 360 and this is 720 and this difference is a big one. This is 36 fours are 144, and so we have to subtract it. So it is 8 and 14 minus 6, 8. Then 13 minus 3, 1080. Then you need to take the HCF of all of these. Again, that will come out as 24. Okay, so by option, we can check it faster, right? So this is my answer, option D. All right, afterwards, this question, find the largest number dividing this and this, leaving the remainders 7 and 12. So first of all, we need to subtract the remainder. Now, this is a different remainder question. Here we need to subtract the remainder differently, right? Now what we can do is subtract the remainder. 2, 7, 6, 1 is left, 7 subtracted, and this will be 3, 4. This becomes 7 and this becomes 5. Now just check the difference. 7 minus 1. We know the difference is the HCF or the factor of HCF. So take the difference. 7 minus 1, 6. 15 minus 6, 9. And 13 minus 7 is 6. So 696 is what I am getting. And is it cancelled by 97? No, 97 is a prime number. And 97, I will not get 8 times also. 8 sevens are 56, 8 nines are 72, plus 5, 77. This is not cancelling. If you check this by 57, you can see 7, 3, 4, 12. 9 minus 2, 12, 5, 6 minus 1, 5. So what is the difference? The difference is 696. Now we need to check this difference divisible by this or not. So just check, is it divisible 57? Check it. 57 ones are 57. What is left? 3. Sorry, it's 2 and 126. 57 twos are 114. So it's not cancelling. 696 cancel by 67. Just check. 696 cancel by 67. 26. No. Okay. Next. 87. Check whether this is divisible by 87. So 696 divisible by 87. Just check. 87. 7 8s are 56. So 5 and 8 8s are 64. Absolutely. 7 8s are 56. So this is absolutely correct. That means it is cancelled by 87, and this has to be my answer, option D, right? So subtract the remainder. After that, whatever comes, just find the HCF of that using the difference method. I hope this is clear. Let's move on to the next. Find the greatest number dividing this remainders, this and this. Again, practice question. So 906 minus 5, 901. 1029 minus 9, 1020. So what are the factors? So by just seeing it, I can sense that 102. Okay, what is the difference? Although we can check 10 minus 1, 9. And although we can check it like this, 900 to 1000, 100 plus 19, 119. Now 119 is not in the option, but I can write the factors. That is 17 into 7. And you know what is the highest among them? Greatest we need to find. The answer is 17. And just check, 17 must divide it. 17 5s are 85. 51, yes. Then 17 6 are 102, yes. So answer is 17. Again, the same type we have just. It's saying that if PQ be the HCF and LCM of two algebraic expressions M and N, and P plus Q is equals to M plus N, then find the value of PQ plus QQ. Let's take some numbers. Let's take P as 3 and Q as 2, right? 3 and 2, fine. And now what is, let's take this, sorry, not P and M, it is M and N. Expression is M and M. So let's take M as 3, N as 2. Okay. Now what is the HCF? HCF is 1. What is the LCM? LCM is 2 into 3, 6. As we have discussed in this class only, that LCM is always the product of two co-prime numbers. And here the two co-prime numbers are 3 and 2. Right? Fine. So this is LCM is 6. First thing. Now it's saying that it should be like P plus Q. Now this is given as P, which is the HCF, and this is given as Q, which is the LCM. So this is Q. But here the condition is P plus Q must be equal to M plus N. So P plus Q is 1 plus 6, and here it is 3 plus 2. It is not equal. That means we can't take this number. We have to take that number where this condition satisfy. So if we try with the basic one, the condition will satisfy for, let's say, M is equal to 1, n is equal to 2. What is the HCF? 1 and 2 HCF is 1 and LCM is 2. Now you can check, and this is the value of P, this is the value of Q, and you know that what is P plus Q? P is 1, Q is 2, and here also M is 1, N is 2. In this case, they are equal. In they are equal, that means we can take this case. So 1 and 2 has to be the value of P and Q as well as M and N. Now it is saying what is P cube plus Q cube. So P cube is 1 cube, Q cube is 2 cube. That must be equal to this. That is 1 cube plus 2 cube again. So what is my answer? My answer has to be M cube plus N cube. This is option D. A good question again. Right. All right. Next one. The maximum number of students among whom 1001 pens and 910 pencils can be distributed in such a way that each student gets same number of pens and same number of pencils. Now, question is, there are total 1 pens and 910 pencils. It is saying that each student, there are students sitting, right? And each student must get the same number. That means the equal number of pens, and here also equal number of pencils. Whatever number of students are there, they must get equal number. So whenever we talk about equal number, we have to check what is the maximum value. What is the maximum value we can give to a single individual student? Maximum value. And that maximum value is always the HCF. So basically, we need to find the HCF of these two numbers. Let's find the HCF. Means highest common factor, means highest is what we can distribute to every student. Yeah. So what is the HCF? We can check it out from here only directly. They are cancelled by 91. You can see very easily. 910, they are not cancelled as this is not having 0. This is not possible. They are not cancelled by 1001 as 1001 is only 1. The other number is less than that. 1911, obviously they will not cancel. So what is my answer? It has to be 91 pencils and 91 pens, which are to be distributed equally to all the students, right? So it's a question of application of HCF. Right, next. The area of the floor is this much, and so this is a floor. This is filled with square tiles, like this. One square tile, another square tile. Don't feel it if it is not a square. It's just a representation. So these are all square, right? Like this, I have to fill this tile. Yeah. Now, it's saying what is the maximum area of this tile. Again, the question is, if every tile is having the maximum area, that means the number of tiles will be minimum, because if every tile is allowed which is having a maximum area, so we have to have lesser number of tiles. So remember, whenever this maximum area, then we can only use minimum number of tiles. If minimum area, we can use maximum number of tiles. The first step is to find that whether we are having what is the maximum size. Before area, I have to find the maximum size of tile. So if this is the maximum size of tile, will be the HCF of this. Overall area of the floor is given, right? Area of the floor is given. This is the area of the floor, that is how much? This is 84, this is 44. So first I have to find this complete area. Afterwards, I will try to find the maximum area of the tile. And before that, I will find the maximum size of the tile, by which I can have minimum number of tiles in this complete floor. So what is the HCF of 44 and 84? Highest common factor of this is 4. So the maximum size of this square tile is 4. So length also 4, breadth also 4. So what is the area? This. So minimum number of tile is area of the floor It has to be area of the floor, right? It has to be area of the floor divided by divided by area of one tile. This is area of floor, yeah, divided by area of entire floor. So you can cancel it. It becomes 11. It becomes 21. 11 into 21 becomes how much? It becomes 231. So what is the maximum area of the tile? That is 4 into 4, that is 16. And how many number of tile minimum you can have? That is 231, and that is your answer. Right. Next question. Three men step off together from the same spot. Their steps measure 63 centimeter. The first person measures 63. Second measures how much? 70. And third measures 77. Now the minimum distance each should cover, so that all can cover the distance in complete steps. That means basically he is trying to say that what is the least multiple of all of these which all can cover, and the distance is covered in complete steps. That means we have to find the LCM. So coming back to the rule of LCM, we know that we have to find the prime factors first. So this becomes 9 into 7, that is 3 square into 7. 70 becomes 7 into 2 into 5. Yes, 77 becomes 7 into 11. Now minimum distance is what we need to find. And so for LCM, what we do, we take the highest power of every number. So what is the highest power? 7 is the highest power here. Fine. 7 highest power is 7. Then we have 3 square. Yeah. What is the highest power of 2? It is 5 only. So it is 2 only. Then 5 is 5 only. And 11 is 11. So just multiply. 9 7 are 63 to the 126. 126 into 11 into 5. So 126 into 5. 120 into 5 is 600. 6 into 5 is 30. So 630 into 11 has to be my answer. Now 11 multiple rule, we all know that we need to write like this. So 6 here, 0 is already 11, 3 is here, 3 plus 0. Now 3 plus 6 is 9. 6930 has to be my LCM, and that is the minimum distance all can cover to complete the distance. Right? Okay. Next question. A man has 26 guavas, 52 papayas, and 91 grapes. What is the maximum he can give to a child if he wants to distribute it equally? Again, the same thing. Every child, there are so many children, but every child has to be have the same value. They have to have the same value. Same value means the highest value possible, right? So what is the HCF of 26, 52, and 91? We know that all are factors of 13. The maximum, it can be written as 13 into 2. This can be written as 13 into 4. This can be written as 13 into 7. So the highest common factor which is here is 13, which is option C. Right? Next question. What is the least number of soldiers in a regiment? Now, this type of question we have done earlier. Now, there is only a form change such that they stand in rows of 15, 18, and 25 and also form a hollow sphere. Hollow square, sorry. Hollow square means the square is hollow. Hollow means like this. See, earlier we have done in the last video, I have done it with a solid square. Same question. Now it is about hollow sphere. Now learn the difference. The difference is when I talk about solid sphere, then the soldiers can stand like this is in this order or in this order. These are the four. These are the four. Are you getting it? Then again, these are the four, and then like this. These are the four. These are the four. And then like this. 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 These are the four right? So basically they have to stand in the square order. In this, complete number has to be a square. In the question of solid square, right? They could be like 1, 2, 3, 4. This is a, or for 4, this is a perfect solid square, right? For more, we can have like, if there are 9 standing, they will be standing like this: 1, 2, 3, 4, 5, 6, 7, 8, 9. So this is the form of the solid square. So this is 4, this is 9. If I want to have 16, this is like this, like 25, one more row of 5. So this is called solid square. So here you need to have this total square as a perfect square. This we have discussed, that what number we need to make this a perfect square, right? But what if it comes to hollow sphere? Hollow sphere means like, if I talk about, say, hollow sphere, it's like, because we are seeing from the top. Understand this, we are seeing from the top. So it is like 1, 2. Now see, here the point is, they can only stand because this is occupied from this side. Are you getting my point? So 4 people can stand like this, 4 soldiers, or it could be 8 soldiers. Like, are you getting? 1, 2, 3, 4, 5. Now 6, 7. Right? I hope you're getting my point. So here they can stand in 8. Like this, total should be 8. See, my point is only this. If they want to stand in a hollow square, they must stand in with multiple of 4. Right? It should be 8. Like this is a hollow sphere. Then 1, 2, 3, 4. Like this, they can stand 5, 6, 7, 8. This is the form of hollow sphere. So either they can be 8, it can be 4, they can be 12, they can be 16, like that. So basically, we need to have a multiple of 4. So in this case, uh, first we'll find the number. So 15 is 3 into 5, 18 is 3 into 2 into 3, that is 3 square into 2, and 25 is 5 square. For LCM, we know the rule. We have to take the highest power available. What is the highest power available? 3, 5. So 3 into 5. The highest power of 3 is 3 square. So I have to take 3 square for LCM. Highest power of 3 among all. Now highest power of 2 is 2 only. Highest power of 5 is 5 square. So this is my LCM. Now, okay, this is 3 square into 5 square, fine. But this is just 2. And I need a multiple of 4. Remember, we need a multiple of 4. So I need to multiply this by 2 also. So what I will get, although 9 into 25, that is 2 to 5, and 2 to 5 into 4 becomes 900. So answer is by chance same, but the concept is that they have to stand here with multiple of 4. They have to stand here with multiple of 4 if we talk about the hollow square, right? So that's all for this session. I hope you have enjoyed it. Thank you so much for watching.